when we have a function here, like this one, f of x, okay? Now, if we add a number to the end of the equation, it's going to go up. And if we subtract a number from the equation, it's going to go down. And that's what this is telling you. That's called a vertical shift. So when we go here, what does k do to it? So k is the number on the outside. So just so we're clear, if we have something like y equals f of x, and if we add something to it like plus k or minus k, that's going to move the graph up or it's going to move the graph down. So when we get in here, we can type that in here. What is k? K is at the end, right? So we set the, well, if k is greater than 0, the graph moves up. If k is less than 0, then the graph moves down. So forth and so on. Now, so they're calling the blue graph the original. They call it the parent, and then the black one is the child. So what is the value of k? So all you have to do is find a matching point right here. So you'd find a matching point, say, pick a point in your mind that's clear to be able to distinguish. Well, let's say they get that one right there. Well, if you have that one, you just find out a corresponding point that goes with it and count the number of spaces. So it's going to be 1, 1, 2, 1, looks like 2, and then 3. So it looks like k is going to be, in this case, since we're going down, k is going to be negative 3 because we're going down. You just count the number of spaces. Okay, so let's move on. Now again, the blue is the parent graph and the black one is the new one, or the child graph. So now you might notice that we're taking a look at a number inside the parentheses right here. See that? So we're talking about changing a number inside the parentheses. And if we do that, that's going to be a horizontal shift. That means it's just going to move sideways left, or it's going to move right. So that's what we're looking at right there. So for instance, if x is positive, we're going to go to the right, okay? Because takes a positive number to make this 0. So if it's positive, we're going to the right. And if it's negative, we're going to the left, okay? So there you go. That's a horizontal shift if the number inside the parentheses is different than just x. All right, moving on. Now, describe the effect of h has. Well, right? We can say it moves the graph horizontally. If h is greater than 0, it moves right. If h is less than 0, it moves left. And there you go. Okay, now we know, we still remember that the blue is the parent and the black is the child. So in this case, we're asking for what's the value of h? Well, h is that horizontal shift. Okay. So we're taking a look right here. So take a point that we can match up pretty easily. Say that one right there and say, oh, how many points? Oh, that matches up with this one, so it's just 1. So it's h is going to go to the right 1, so h is going to be positive 1. That's it. Okay? That's what's happening right there. So here, we are multiplying by a number on the outside. All right, so pay attention here. Here, we're multiplying by a number on the outside. So in the first, we did a number over here. This was vertical changing out here. At first, we're adding a number on the outside. Then we change the number inside the parentheses. Now we're multiplying by a number on the outside. That's called a factor. Okay, it's a vertical factor. So let's see what happens when that number changes. that's going to stretch or shrink. So it's not going to move it horizontally, but it's going to move it. It's not going to move it vertically. It's going to stretch it or compress it. Okay. So if it's positive, it's just going to be compressed and go up like that. And if it's 1, it stays the same. And if it's negative, it inverts. Okay. So that is a vertical stretching or shrinking. Okay. That's there we go. So that's a stretch up, and it's a flipping right there. So it's a vertical stretch. Let's describe what A does to the graph. Well, you can say A stretches the graph vertically. It goes upward if positive and downward if negative. Let's go back to the original graph. What if it's between 0 and 1? Let's say it's between 0 and 1, that's 0.2. So there's the original. It goes down. It's still above the x-axis, but it goes down. So I'm going to go to that statement that we're just writing. Okay, so it goes up if greater than 1. It's probably more accurate. It's greater than 1. And it's downward if less than 1. Okay? But we could say if it's positive, it's above the x-axis, right? So positive is above the x-axis. Positive above x-axis, right? And negative would be below x-axis. Moving on. Now, let's take a look at if A is only greater than 1. See, if A is greater than 1, boom, that's what we just said. It just goes up. So if A is bigger than 1, moves up vertically. So A is the number multiplied on the outside right there. That's what we're talking about. So if A is bigger than 1, what happens to the child graph? Well, it moves upward. All right. What is the value of A and the child graph's value of A? Well, we have to find out what that is. So what we do here is we look for corresponding points that match up, right? So let's say like take a point, let's say right there, and take a corresponding point right there. Sorry about that. Zooming things a little out of control. It goes from a 1 to a 4, so that looks like A is equal to 4 here. It looks like A equals 4. All right, moving on. So let's see what happens now. This thing is built where A is less than 1. So what happens when A is less than 1? Between 0 and 1, it goes down to the x-axis. Okay. So let's get that again. Get that again. It's between A is, so it starts out at 1 would be the original graph. If it's between 0 and 1, it goes down, but does not go below the x-axis because it's positive. Okay, so it's between 0 and 1, it goes down to the x-axis. It flattens toward the x-axis. Now, let's see what happens here. It's just so A is -1, so -1 it's going to flip. So it flips the graph over the x-axis. That's what's happening right here. Okay. So it is a sine function as I thought. So it's flipping over the x-axis. So describe the effect that A has on the child graph. It flips the graph over the x-axis. Okay. sometimes we have multiple transformations at the same time. Well, if we change this, that's going to be our vertical shift. It's going to go up. It's going to be with the flex axis, it's going to invert down. So that's one change. Then you have the horizontal change, which shifts it. That just shifts it horizontally, left and right. Okay. Let's put this A back to 1. And then K is the outside. It's going to be like our vertical. It's like our y-intercept. You might think of it as from algebra. So it's moving it up, it's moving it down. That's what's happening here. Okay. So you could have multiple changes at the same time. So we're asked to find the values of H, K. Well, we can find, this is definitely a flip. So you could see that A, H, and K. They're asking us to find a little challenge here. Well, I look at this point right here. It's peaked at 1, and this one's peaked at 2. So it looks like our A might be a -2 because it's flipped. You see how the peak is on the top, and now here the peak's on the bottom, and it's a factor of 2, vertical stretch. Now H is going to be how much it's moved sideways. So if you move it from here, I think I should probably put a pointer here. So you can see the depth of this right here. The depth of this right here is 1, and the depth of this right here is, that's 2. So that way that's, so we flipped it upside down. We flip, it's going to make A negative, and it's a 2 because it went upside down. It's a factor of 2. Let's go back. And H, did we move it sideways at all? Yes, we did. We went from here to here, so it's 4. 1, 2, 3, 4, the endpoints. So I'm talking about this right here, and this point right here, and this point right here. Okay, that's this distance of 4. That's 4 spaces. So let's try. So let's say H is equal to maybe 4. And K is moved up or down. Let's see how many spaces goes up or down. Well, it looks like 1, 2, 3 spaces up. And then you submit your answer there. Kind of cool, huh? All right, so we're going to go through my open math shortly, do some of those problems in there. So when you're trying to figure out a horizontal shift from a vertical shift from the formula, vertical is going to be, so vertical is added at the end, so it's K. That's the K value at end. And the horizontal shift is the H value that's next to the X inside. The key thing is inside parentheses, okay? Horizontal changes have to do with values inside the parentheses, and vertical basically have to do with changes outside the parentheses. That's the key thing to keep in track there. Horizontal stretch and vertical stretch. So these are stretches. Now these are, the first one was shifts. So that's when you add a number, add or subtract a number. When you talk about stretches, then you're talking about multiplying, okay? So if you're doing a horizontal stretch, again, horizontal, that's inside parentheses, right? So it's inside parentheses, and you're multiplying. So a stretch has to do with multiplying, and a shift has to do with adding or subtracting. That's the key thing you want to keep track of. So vertical has to do with outside, and that outside parentheses, and that is multiplying. So they're both multiplying, but one is multiplying a number inside the parentheses, one is multiplying a number outside the parentheses. That's the key thing to keep in track of there. Respect of the x-axis. So, well, typically here, if you're multiplying A, when A is negative, then we're going over the x-axis like we just did in Desmos. Okay. And then when we go over the y-axis, then we're going to have